Now, manipulating images is a foundational skill in computer vision. Today, we're going to explore how to resize, crop, rotate, and even draw on images using OpenCV. This is video 15 out of 20 in our beginner series, An Introduction to AI. Now, let's take a quick look at this first function. If you look at this cell here, I've decided to this time import both CV2 and matplotlib pyplot. This is basically used to take the images that we generate using the CV2 library, and in the convenience of the Jupyter Notebook, I'm going to simply pass it to the plot method and then show it off here. That way all of our results will remain in the same notebook instead of popping up in different sort of files that we saw in the last video. Now, let's take a quick look and run through this entire sequence. You'll notice that the logic behind this code block is pretty straightforward. First, I use the CV2 library, I call upon the image read method, and I load the starbunny JPEG to this image variable. The image variable is then passed to the resize method, and this time given the parameters of 300 and 200 to resize it, and then saved to the variable resized. Then, in these last two segments, they simply allow me to plot the image, and voila! When we run this cell, you'll see that in the original starbunny image, we have, as expected, a 1024 by 1024 composition, but in the resized starbunny, we now actually have the image quality both compressed and the dimensionality in the plot totally matches what we expect. In other words, this is evidence that we have been truly seeking to demonstrate that resizing clearly changes the image's dimensions, and whether or not you're scaling up or down, OpenCV makes this very simple. So now let's move over to the next block. This is a vestige from another script. And now let's look at the concept of cropping. Now in general, the cropping logic is basically defining the subsection of both the Y slice, or the Y-axis slice, and then the X-axis slice. So I randomly chose these two different segments, and then I'm going to crop a different part of starbunny and illustrate it. And it looks like we just got a really nice sort of starry night. You don't even see starbunny in this image. Cropping allows us to extract a region of interest from the image. And as you can see in the syntax, it's as simple as slicing in Python. Now this is where things get really interesting. Rotating an image is what we are now going to demonstrate next. As you can see here, I'm going to take the raw image of starbunny, and then what I do is I have to identify its center. What you might be wondering is, what are these brackets that follow image.shape? Well, if you remember what image shape returns, you'll recall that actually image.shape returned the height, the width, and then the number of channels. When you pull the index of the dictionary value shape open bracket 0 close bracket, that gives us the height or width, and then shape open bracket 1 gives us the other corresponding height or width. Likewise, when I take both of those dimensions and then I have it in 2 or divide by 2, that brings me to the center of the image. Taking that value of the center, I then pass that into this next function of CV2 called getRotationMatrix2D, and I take those center coordinates and I pass them as the first variable. CV2's method getRotationMatrix2D then allows me to also specify the degrees of rotation I want in the second variable. In this case here, I'm passing it as 45, and then 1, which is the dimension. And so that is the value of matrix. Finally, in the rotated variable, this then passes, this stores the output of warp affine, which then takes my raw, again, image, the underlying matrix, and then of course, the center point of image.shape open bracket 1 and image.shape open bracket 0. In other words, the dimensions of the image's height and width. And so when I run this script, you'll notice that we now have a rotated starbunny. And that's too easy. But what we love about this type of script is that this actually can be used in many types of supervised machine learning tasks to help begin augmenting your underlying data stores and giving you data diversity that you might not otherwise have. So let's now keep going. In the last section, we also have to realize that in image manipulation, you can also actually draw rectangles, circles, and in general, shapes onto your star bunny. These parameters that are passed to cv2.rectangle or cv2.circle can all be applied to the image value. And of course, some of these parameters simply specify the color. For example, here, 00255, designating the color of our circle, whereas here, 02550, designating the color of some rectangle. So let's just see what this looks like, because drawing shapes can be useful for annotations, highlighting regions, or even creating masks. And as you can see here, the circle with the last channel filled in renders a blue circle, while here, the rectangle with the middle channel filled in of 255 renders a green circle. Now, let's take one final look at the ability to actually even add text to your image. One way to do this is to utilize font, and specifically call on CV2 the font Hershey simplex, which simply takes some fonted text and allows you to put text onto your underlying image, which occurs here in CV2 dot put text. And if I run this, you'll see that my own text with OpenCV is now articulated as well. Adding text to images could actually provide context, labels, or any other necessary information that you might expect, especially when you're working on computer vision-like algorithms. All right, team, this is video 15 out of 20 in our beginner series on Introduction to AI. By the end of this series, you'll be ready to learn more advanced concepts of AI and machine learning, which will allow you to elevate your career in tech and remain in demand on the job market. Mastering image manipulation is just a stepping stone in computer vision. With these skills, you're well on your way to becoming a proficient computer vision engineer. Keep experimenting and exploring with OpenCV.